Alright, so let's talk about set builder notation. Alright, set builder notation. Set builder notation is simply another set of way of expressing items in a set. Alright, so instead of the traditional method I've been teaching you, where they'll just tell you A is a universal set and the numbers in the set are 1, 3, 5. Set builder notation is something such that they will define what those elements are, and then you can now be the one to fill in that subset with the elements. For example, you can just be told that A is a set whereby A represents cars. That's all you'll be told. So you are the one that will now know, okay, since these sets, the elements in the set have been told they are cars, that means I should have Toyota, I should have Lexus, I should have Honda, I should have Prado. You'll be the one to fill it up with details from your understanding of what cars are. That's basically what set builder notation is. So you will not always be spelled out the elements of the sets for you. Sometimes you will be the one to generate those elements of the set from your understanding of the way it was arranged in the question. Take for example this set. It says A equals to integer or x less than minus x less than 4. What it means is that A is the set of integers. Remember, integers are whole numbers, whether positive or negative, -1, -10, 11, 8, 5, those are integers. So A is a set of integers x, that's why you see A integer x, such that x is less than 4. So what they are telling you simply is that all integers that are less than 4 belongs to the set A. That's the meaning. They have told you here that x is less than 4, and they have told you here that x is an integer. So what are the integers that are less than 4? The first integer that is less than 4 is 3. After that is 2. After that is 1. After that is 0. Then -1, -2, and so on. Alright? That's exactly what you have here. So you see that you were not given this complete set, but you are expected to be able to understand how to generate all the items in that set from the way it was described. That's basically what set builder notation is all about. All right, so let's look at this is another example down here. You can see that A contains sets. A contains elements x. All right, it contains x where s is less than 4 and x is a natural number. Natural number means positive whole numbers. So we cannot have -1, -2. No. So natural numbers, in other words, are positive integers, only positive whole numbers. So what they are telling you is that s is less than 4 and it's a natural number. So what are those positive numbers that are less than 4? 1, 2, and 3 are less than 4. All right. So 0 is not a natural number. So we start from 1, 2, and 3. That's the elements in that set. So in set builder notation, you may be told to, list the members of a set. They will give you the description, something like what you can see here. And you are the one that will have to list the members of a set. So let's look at this example that's already been done. List the members of the set X such that S is greater than or equals to -2, where S is a... So when you see Z, Z is what we use to represent natural numbers. Sorry, what's it called? Integers. In mathematics, usually we use that letter Z to tell you it's an integer. So they are telling you X is an integer that is greater than or equals to -2. So what is greater than or equals to -2? That means you start from -2 and you move forward. So you have -2. Since it's greater than, what is greater than -2? The next one will be -1. What is greater than? 0, 1, 2, just like that. So we use our understanding of what natural numbers are or whole numbers, the greater than sign, the less than sign. We use our understanding of those things to populate the elements of a set in set builder notation. So look at this question that you are given two different set notations, and you are able to intersect the two sets. All right, you are given an integer that, okay, given that x is an integer. Remember what integer is? It's a whole number, can be negative or positive. Then I told you to list the members of this set x where s is less than 4. All right, intersecting with another set x where that set of s is greater than or equals to -2. So the first thing you do in set builder notation is to understand the question and then populate your sets, populate your data sets with this information. If you are told x is less than 4, what are the numbers that are less than 4? It starts from what? 3, 2, 1, 0, -1. It doesn't even tell you where to end, so you keep going. That's what we have here. 3, 2, 1, 0, -1, -2, -3. It keeps going on forever. Those are the elements of the first set in the question. The second set says x is greater than -2. So you start from -2 and you'll be moving forward. -2, -1, 0, 1, 2, 3. That's the second set, which is what we have right here. So you must learn how to understand the question and populate the data sets before you can use to solve. Now they told you to intersect the two sets, which means look at these two sets up and down. What are the things they have in common? Are there numbers that you can see that they have in common? If they are, pick them out. That's your answer. So basically, if you see both up and down, I can see they have, this one has 4, but this doesn't have 4, so I can't put 4. But they both have 3, they both have 2, they have 1, 0, -1, -2. It doesn't continue anymore. It stops there. All right. So you notice that they have a limited number where they overlap, and it has been written down here. So understanding it is base. Once you are able to populate the sets, you're able to bring out the sets, write it out. Intersection is so easy. Just look at what they have in common, what appears in both sets, write it out, and that's your final answer. So that's basically what set builder notation teaches us. All right. Sometimes you can even be given a normal set and you are told to represent it using set builder notation. Like this example 7, you are told to represent this set using set builder notation. If you notice, what is about these numbers? They are all positive whole numbers. So I can say that they are natural numbers, which is represented by n. All right. So let's say the set is x. All right. If this set A contains numbers x such that x is a natural number. All right. Remember that when I was introducing you to these symbols, I told you that this E means is a member. When you see E, it means member. So what all of this down here means is that x is a member of natural numbers rather. So, but that's just like the second part of the set notation. So how am I going to write the other part? I can see 1, 2, 3, 4. There are so many ways to write it using our greater than or less than sign. So if you look at these options, you can even see the answer. We have 3 options. So any one you write is correct. So you are given that in this person they wrote x, whereby 1 is less than or equals to s is less than or equals to 4. So what this means is that s is less than or equals to 1. So because of that or equals to, it means s can be 1, or it can, and s is less than or equals to 4. All right. So this one is read the opposite way. Since you are seeing 1 is less than or equals to s, what it means is that s is greater than or equals to 1. So if it's greater than or equals to 1, that means from 1 you keep moving forward because it's greater than. You have 1, 2, 3. Where do you stop? The other part tells you s is less than or equals to 4. That is where you stop, because that's what you have in the question. What we are trying to do is to find a way to represent this question. All right. Trying to find a way to represent the question in set builder notations. All right. So whichever method you choose to use to write it is not bad. You can just choose to write. You can see this third example. They just says x is a set of numbers where s is less than 5 and is a natural number. So what are the natural numbers less than 5? It will be 4, 3, 2, 1, and 0 is not a natural number. So that's another way they choose to write the set. They just choose to tell you that this means x is all natural numbers. That's the meaning of n. X is all natural numbers that are less than 5. The first example, the first answer rather, tells you x is all natural numbers that fall between 1 and 4, with 1 and 4 included. So set builder notation, you just basically need to, it's more like common sense. You need to understand that there are several ways of writing something. All right. I mentioned earlier the example of they can tell you a set of cars and you start mentioning Toyota, Lexus, Ford. You can also be told to say something like there can be a different way that that set will be mentioned. They can say a set of vehicles using fuel, and you still end up mentioning those same items. So you can write a set using set builder notation in more than one way most times. As far as you're able to describe it accurately for who is reading it to say, okay, I understand what he's saying. These are the items that fall into this category. As far as you're able to describe it, you have no problem. All right. So that's basically it for set builder notation. So in our next class, we'll talk about Venn diagrams.